Okay, so I have solved all four problems, got some really stupid penalties. That's fine. So let's go through them. So concatenate array with reverse. Okay, so here we're given an array and we have to create an array of double size. First part containing this, second part containing its reverse. Like in 1, 2, 3, it will be 1, 2, 3, 3, 2, 1. So it's an easy problem. Like you can just do I just did a clone reverse, then push that value into the existing vector and then returned it. And I got a penalty because I didn't read the question properly and I didn't reverse the array. That's fine. So that's problem one. Problem two is a weird one. At least the statement is weird. You are given an array of string chunks. The strings are concatenated to form a string S. So basically, you don't have to treat this as a vector of string. Instead, you can just concatenate these chunks and create the actual string as well. Like it won't make any difference. Then we are given queries. Also, we are defined a definition of substring of S such that it contains lowercase characters or one hyphen surrounded by both. Like it can contain multiple hyphens, but it has to be like A hyphen B hyphen C. Like this is a valid scenario, but A hyphen hyphen B C is not defined because each hyphen should have in English letters on both the sides. So if you see this one, it has A here, but it does not have any English character here. So only one hyphen is allowed. So if we see for this hyphen, this has characters at both ends and is not part of a longer substring. So it basically says like if we have this A hyphen B hyphen C, then A hyphen B is not a word. This entire thing A hyphen B hyphen C has to be a word. In this case, like in this case A hyphen hyphen B C, A will be a word and B C will be a word. So these are two separate words. But in this case, we have only one word. And then we have given queries for each query we have to tell how many times that as a word is a appears in the string s. So first of all, as I said, that we don't need to uh, care these as chunks, we can just append it. So I just created a string because the length obviously constraints are won't change, the space taken will be the same, will be almost the same. And then I maintain a frequency. This will store mapping. This will store the frequency of each word, each valid word present in the string. How we compute, we'll come to that. But yeah, so and then we'll iterate over the answer. And for each query, we just check its frequency. Now, how to calculate this frequency? So I first split each word according to spaces. So if we see this, uh, A hyphen hyphen B, A hyphen hyphen C. This is the word. This is the string S. And then if we split it space wise, then this I will get two parts, A hyphen hyphen B and A hyphen hyphen C. Then as it says that hyphen has to be surrounded by English characters. So if any hyphen was present here, then we cannot consider it. So that's what I did first. From the first or last part, if the character was a dash, a hyphen, then I remove the character from both start and end points. So this will remove from end point. For removing from start, I reversed it and then removed it. Like so that it takes linear time only. Like if we try removing the first character in the array or string, it will take a linear for each removal. But here will be constant for each removal, so linear time altogether. So yeah, we remove hyphen from start and end. Then we run a two pointers as long as we have a valid word. So in case of A hyphen B hyphen C, a valid, like this will not contain any spaces obviously because we are split according to the spaces. So if we do a hyphen hyphen b, if we iterate over these two, so our breaking condition would be if this word, like if we split it by space and then the individual string part can have multiple words, then it will be this scenario only. Like if a hyphen hyphen b is there, then these two hyphens are a breaking scenario, so a will be a word. So that's how I ran two pointers. So I start with the left part. If it is already hyphen, ignore it. So we start with an alphabet, obviously. Then we run two pointers until we get two consecutive hyphens. If w of I minus 1 is d and w of r is d. Until this condition is true, so we have a not here. Then till then we increase r. And now here two cases. Like we could have gotten like a hyphen b hyphen, let's say, or a hyphen b hyphen hyphen, or a hyphen b. So in these two cases, like the right part would be here. The right index would be here for each one, like at the end. So if w of r minus 1 is d, like the dash here, let's say, so we move one space back. This happens because we take the range from L to R, L inclusive, R exclusive. So that's why I've done it. Like at max, it will have one hyphen A which we have to handle. Then we check the string of W from L to R. Here R is exclusive, L is inclusive, and we increase the frequency for that one word. And then obviously we do L to R as we do in the two pointer sliding window idea. And then we continue our iterations. So for each string separated part, we find the individual words inside it. So here is the penalty I got here. That's how I expected this problem to be such a weird one. So queries can also have this hyphen here. And at that point I didn't understand. I thought that both space and hyphens can be a delimiter here to split. But yeah. So this is the idea. This is the idea for second problem. Third one. Okay. So here we are given an array and we are allowed to choose two numbers in the array such that one is divisible by other, and then we can replace the larger one with the smaller divisor, and then we have to tell the possible sum of array. So if we see this first example 3 6 2, 6 satisfies this condition with both 3 and 2, but we will choose it with 2 because getting 2 is the smaller better option here. We could have got 3 3 2 also, but that is not smaller. 3 2 2 has a smaller sum. So basically the idea is for each number we will find the smallest factor present in the array. So I have used a sieve idea for this. So for each number I'll store the smallest factor present in the array. So initially if we see to 6 only, 4 5 6, 1 2 3 4 5 6, okay. So 2 is present. So 2's smallest factor so far we will have 2. Like this is 0 based index, but we don't really care about 0 here. 2, 3 and 6. These are the values present here. Now we will 1 2 3 4 5 6 positions. We will iterate over 2's multiples and set these values to 2, and then we'll iterate over 3's multiples, and here it is already 2, so we will not apply it. So we'll find a minimum one. So this is the idea. We'll iterate over the numbers in the vector, and then we'll iterate over its multiples. So the time complexity for this will be like if you start with 1, you will traverse n numbers. For 2, you will traverse n by 2. For 3, you will traverse n by 3, and so on. So this comes out to be n log n. This is a known fact. And then we will for finding the final sum of numbers, we just choose the smallest factor we have found in this answer array, like what we initialized. I got one penalty here because I did a wrong assumption. Like if you know the general sieve idea, we sometimes start from I cross I here. So that's what I did, but that is not necessarily the scenario. Like we don't have always deal with the smaller factors first. Like in this case, 14 is 2 times 7, but 2 is not handled here. So we should have just started with 7 only, 7 or 14 only. So instead of I cross I, it should be either I or 2I. Yeah, so that's the idea for the third problem. Fourth one. Okay, so this is also like an implementation problem only, since the constraints are small. So here we are given a graph, and each edge has a cost and a tax. So if we are not carrying apples, so uh, so if we have a graph of some sort, so if we go 1 to 4, so if we are 1 and we want to buy apples from the fourth node, so we go 1 to 4 here without with only the cost, and we go back here, cost multiplied by tax, because we also have the apples here. So the and we are like we are at start with node 1, let's say, and we have to tell the minimum cost to buy apples. So here we are not about any quantity of apples, we just want some apples. So we are given the price of apple at each node, the cost and tax for each edge. So it will be from 1 to 4, the cost, the summation of cost over the path, plus price at 4, plus 4 to going back to 1, the summation of cost into tax. That is the idea. So as I said, since the constraints are small, we can do like a Dijkstra's algorithm on the shortest path idea from each node. Like it takes n log n time for one node. So for 1000 we could do n square log n. So if we see the implementation, I wrote a Dijkstra. So this will do this will start from the route I pass here, update the distance accordingly, and for the weight, if I passed a with character here, if we are traveling with apple without apple. So if we are traveling with apple, then it will be the cost multiplied by tax. Otherwise, it will be only the cost. And then we do the simple extra, and then we store distance with apples or distance without apples using the Dijkstra algorithm only. So here we can create, this will take n square log n all over time. Yeah. And then we have to find the answer for each node, the minimum price we can have, like minimum cost to buy apples starting from the node I, basically. So the minimum here you can see that tax is only 100 but cost it's in power 9. So if we multiply these, we can get integer overflow, but the answer already always measures vector I32. The reason for that is, in the worst case, we decide not to travel but only to buy the apples from that node. So the maximum answer cannot exceed price of I for ith node. So it will be in I32 only, even though the extra might give us something else. Yeah. So instead of declaring answer as an empty array, I declared it as a clone of prices. Then I start with each node. The total cost is like the answer for node I. I first initialize with infinite, and for each other node, for I not equal to j obviously, then we find total cost from distance without. We go from I to j, we buy it at j, and then distance with j to I. And then we see if it fits in I32, only then we will consider finding its minimum with the price. So yeah, that is the idea for fourth problem. So yeah, that's it from my side. Thanks for watching. Bye.